Alright, so let's talk about the dot product. Okay, so the dot product on its own, it's kind of useful. We can use it to calculate work and stuff, but together with other things, we can use it to determine the distance between, or the angle between two vectors. There are also various uses in physics, biology, engineering, so it is a useful tool to know. Alright, so if we have vectors A and B, then the dot product. Now the dot product is kind of confusing because it's almost the same dot that we use for multiplication. So I'm going to draw it pretty big. Okay, so if you see a big dot, that probably means that we're using the dot product. I'll also try to write down, use the dot product. So the dot product of A dot B is that we take A1 and we multiply it by B1, then we add it to A2 times B2. Right, and then we're going to get some number. So it's not going to equal another vector, it's going to equal a number. Okay, so let's do an example. Let's say that we have A equals -5 and 7, and B equals -1, 2. Then A dot B, right, so A dot B, not A times B, is going to equal -5 times -1 plus 7 times 2, right? So -5 times -1 is going to give us a +5. 7 times 2 is going to give us a +14. And I get the dot product between these two is 19. All right, so you should always get a whole number. If you get another vector, something's gone awry. All right, so let's see how it helps us find the angle between vectors. So we get this neat formula. We get that theta equals cosine of -1 of A dot B, so that's not multiplication, that's the dot product, over the magnitude of A times the magnitude of B. All right, so like let's say, for example, that this is my vector A and this is my vector B. Then what this is going to give me is it's going to give me the angle between them. All right, so before we get into it, here are some neat rules that you should know. You should write these down on your note card. So if you take A dot B, so this is before you even calculate the length. If you just take A dot B, if that equals 0, then A dot B are perpendicular. All right, so that means that they form a right triangle between them. Okay, if we have A dot B equals 1, that means that they're parallel. Right, so that would be like this. Okay, and then if we have A dot B equals -1, then we know that A and B go in opposite directions. Okay, so we have that there's a 90-degree angle, that there's a 0-degree angle, because they'd be overlapping each other, they'd be going the same direction. And then we have 180 degrees, meaning that they would be going opposite directions. All right, if A dot B equals -1. Right, so let's go ahead and derive this formula. You guys would be surprised. We actually know enough to get this formula on our own. So, how did they come up with it? Well, let's go ahead and draw two vectors. So, if I have vector A over here, right? So let's say that A has horizontal component A1, A2, and give its length as the magnitude of A. Okay, and let's say that our vector B has horizontal B1, B2, or vertical B2, and has length magnitude B. Now let's make the standard angle created by A, let's make that alpha. Let's make the standard angle created by B beta. And let's make the angle that occurs between them theta. Okay. Now, if we were to take cosine of alpha, we know that that would be A1 our horizontal component, over magnitude of A, that sine of alpha would be A2 over magnitude of A, cosine of B would be B1 over magnitude of B, and sine of beta would be B2 over magnitude of B. Right? That's not too hard to imagine, since this distance here is A1, this distance here is A2, and the length of this vector is magnitude A. So this fall out pretty easily. Now, I know that if I wanted to find theta, that it would be the angle beta minus alpha, right? So theta is equal to beta minus alpha. So let's also write that down. So theta equals beta minus alpha. Now, then I know if I take the cosine of theta, I know that that would be equal to taking the cosine of beta minus alpha. Okay, so the cosine of theta is equal to cosine beta minus alpha. Well, we are so smart and know law, or the sum and difference formulas, that we know that cosine of beta times cosine of alpha plus sine of beta sine of alpha is equal to that. Right, now if I substitute in cosine of beta, right, so instead of having cosine of beta, I'm going to substitute it in for B1 over magnitude of B. Right, for cosine of alpha, I'm going to substitute in cosine of alpha for A1 over magnitude of A. So let's go ahead and just write that down right here. So we're going to substitute in B1 over B. This guy is A1 over magnitude of A. Similarly here, B2 over magnitude B, and that's A1 over A. Alright, so all I did was do some substitution, right, as I have written down here. Alright, so now you'll notice here that I have a common denominator, right? My common denominator for both of them is the magnitude of B times the magnitude of A. So that means that I can put them together, and I get A1 times B1 plus A2 times B2 over the magnitude of A times B. Now remember that the dot product of A dot B was A1 times B1 plus A2 times B2, and that's over the magnitude of A times the magnitude of B. Remember that this equals cosine of alpha still, so this guy's just been dropping down with us as we go. Right, so now to find theta, we're going to take cosine inverse of both sides. And that's how we get that theta equals cosine inverse of A dot B over magnitude A times magnitude B. Okay, so that was just for fun. You guys don't need to know how to prove that. So let's go ahead and do some more examples. Okay. So if I let A equal -4, 3, and B equal 1, -2, I need to find the angle between them. Okay? So what I'm going to do first is I'm going to get all the pieces I need. So let's see, if I write this down, then I need cosine inverse, and the stuff I need inside is A dot B, and I also need the length of A, and I also need the length of B. So I'm going to calculate those up here. So first I'm going to do A dot B, which is -4 times 1 plus 3 times -2, and that's going to give me -4 plus -6, and that gives me -10. All right, now to find the length of A, or the magnitude, which are interchangeable, magnitude and length are the same thing, that's going to equal my A squared, so that's going to be -4 squared, plus my A2 squared. Alright, so that's going to give me 16 plus 9, that's square root of 25, so that just equals 5. Alright, then I need to find magnitude of B. That's going to be the square root of 1 squared plus negative 2 squared. Right, and that's going to give me square root of 5. Now that I have all of my components, I know that theta equals cosine inverse of A dot B. Since A dot B equaled negative 10, that's going to be negative 10 over the magnitude of A times the magnitude of B. Right, and then if I enter that into my calculator, let me see what I get. I get that theta is about 153.4 degrees. All right, notice here that my A dot B was not negative 1, 1, or 0. Okay, so that tells me that my horizontal and vertical components are not perpendicular. Okay, so let's move on. So the work I have to exert on something is equal to F dot B, where F is my force and D is my distance. Okay, so if I let my force equal 3, negative 2, and I move an object from point P to point Q, then I need to find the work that was done. Okay, so first I need to find the vector PQ, which is going to be 3 minus negative 2, negative 1 minus 1. So that is going to give me 5, negative 2. And that's going to give me my distance traveled. Okay, so that's going to be my D. So then I have my F, and I have my D. I just need to do F dot D, which is going to give me 3 times 5 plus negative 2 times negative 2, which is 15 plus 4, which gives me 19. Okay. Now let's say that my force was pounds and my distance was feet. Then this answer would be 19 feet pounds. Okay. All right. And that concludes the lecture portion of section 8.3.